Picture yourself stepping off a ladder onto the moon's surface. No breeze touches your suit. No sound carries across the horizon. The sky above isn't blue or even dark in a familiar way. It's a depthless black, a void so complete it feels like it's pressing against your visor. The ground beneath you looks soft, almost inviting, a blanket of pale gray dust stretching in every direction. It seems calm, frozen, timeless, but that calm is a deception. For generations, we've treated the moon like a quiet companion. It rises and falls with comforting predictability, a glowing disk that has watched over humanity since the beginning. We've stared at it through telescopes, traced its craters, written poetry about it. We've even stood on it. Humans walked there, left footprints, planted flags, and came home safely. That history gives the impression that the moon is understood, tamed, even. It isn't. The truth is, we barely scratch the surface of what it means to exist there. The Apollo missions were brief encounters, lasting days at most. They were not long enough to reveal the moon's deeper hazards. What we've learned since then, through decades of research, simulations, and analysis, paints a far more dangerous picture. The first warning signs came almost immediately during those early missions. Before astronauts even left the lunar module for the final time, they noticed something strange. The dust, fine, gray, and seemingly harmless, was causing problems. It clung to everything. It coated their suits, worked its way into joints and seals, scratched visors, and it interfered with instruments. Brushing it off didn't help. If anything, it stuck more stubbornly, as if it were alive. When astronauts re-entered the lunar module, they brought that dust with them. In the moon's weak gravity, it didn't fall to the floor like dust on Earth. It floated. It lingered in the air, drifting through the cabin like smoke that refused to settle. And then came the symptoms. Within hours, astronauts began experiencing irritation. Burning eyes, sore throats, congestion. One described it as a kind of lunar hay fever. Sneezing fits, watery eyes, and inflamed sinuses followed. It wasn't just discomfort. It was a direct physiological reaction to something alien. Even the smell was unsettling. Every crew reported the same thing. A sharp, acrid scent, like burnt gunpowder. That odor came from the dust itself, reacting chemically with oxygen for the first time inside the spacecraft. Because on the moon, that dust exists in a completely different state. For billions of years, the lunar surface has been bombarded by micrometeorites, tiny fragments of rock traveling at extreme speeds. Without an atmosphere to slow them down, they strike the surface directly, shattering rock into incredibly fine particles. But unlike dust on Earth, these particles are jagged, sharp, and chemically reactive. Each grain is like a microscopic shard of glass. When those particles encounter moisture, like the inside of a human lung, they don't behave passively. They interact. They stick. They embed themselves deep within tissue. And because they are so small, many of them can bypass the body's natural defenses entirely. On Earth, dust is often filtered out or expelled. On the moon, the situation is very different. The lower gravity means particles remain suspended longer, increasing the chance of inhalation. Once inside the lungs, the smallest particles can remain there indefinitely. That raises a serious question. What happens after weeks, months, or years of exposure? We don't fully know yet. But there are clues. The composition of lunar dust includes materials similar to those that cause serious lung diseases on Earth. Some components are known to trigger inflammation and long-term respiratory damage. Others are chemically active in ways that could disrupt biological systems at the cellular level. Short missions revealed immediate irritation. Longer missions could reveal something much worse. And the dust doesn't just sit still. Under the intense radiation of the sun, the moon's surface undergoes a strange transformation. Ultraviolet light knocks electrons loose from the soil, creating an electrical charge. Tiny dust particles can become charged as well, and once they do, they can lift off the ground. They float. In some regions, these particles hover above the surface, forming a faint, shifting layer of suspended material. In others, especially near the boundary between day and night, electrical forces may push dust sideways across the landscape. The result is something almost surreal, a world where the ground itself can rise into the air, where invisible currents move particles in slow, ghost-like motion. Now imagine breathing in that environment, and that's only one part of the danger. Radiation is another. On Earth, we are protected by two powerful shields, a magnetic field, and a thick atmosphere. Together, they deflect and absorb most of the harmful radiation coming from space. On the moon, neither of those protections exists. There is no magnetic field, no atmosphere, nothing between you and the full intensity of space. High-energy particles, some originating from distant supernova, pass straight through the lunar surface. They pass through spacecraft, through human tissue, through DNA. Over time, that exposure adds up. It damages cells. It increases the risk of cancer. It can impair the nervous system. And because these particles are so energetic, shielding against them is incredibly difficult. In some cases, adding more material can actually create additional radiation inside a habitat, as incoming particles collide with shielding and produce secondary cascades. Then there are solar events, sudden bursts of radiation from the sun. These are unpredictable. When they occur, they can flood the moon's surface with high-energy particles in a matter of hours. Without proper protection, an astronaut could receive a dangerous dose very quickly. Past missions were fortunate. They happened during relatively quiet periods. But luck is not a strategy. Future missions, especially long-term ones, will need to account for these risks in ways we have never attempted before. And then there's the temperature. The moon experiences extremes that are difficult to comprehend. A single lunar day lasts about 2 Earth weeks. During that time, the surface is exposed to constant sunlight, heating it to temperatures hotter than boiling water. Then comes the night, another 2 weeks of darkness, during which temperatures plunge far below freezing. There is no atmosphere to moderate these changes. No wind, no weather, no buffer. Just raw exposure to space. Materials expand and contract. Components weaken. Systems fail. Short missions can endure this. Long-term infrastructure must survive it repeatedly, over years or decades. Even the ground itself isn't as stable as it once seemed. The moon is slowly shrinking. As its interior cools, it contracts. This creates stress in the crust, which has nowhere to go. Unlike Earth, the moon doesn't have active plate tectonics to release that stress gradually. Instead, the crust cracks. These cracks form ridges and cliffs across the surface, evidence of a world that is still changing even now. And when those stresses are released suddenly, the moon shakes. Moonquakes. Some are deep and subtle. Others originate closer to the surface and can be surprisingly strong. But what makes them especially unusual is how long they last. On Earth, seismic waves dissipate relatively quickly. On the moon, they can continue for hours. The ground doesn't just shake, it resonates. In a landscape covered in loose, fragmented material, that prolonged motion can trigger landslides, shift boulders, and destabilize terrain. For a permanent settlement, that's a serious concern. Finally, there's the constant rain of micrometeorites. Without an atmosphere, even the smallest particles strike the surface at tremendous speeds. Individually, they may seem insignificant, but over time, they erode materials, weaken structures, and pose a continuous threat. Spacesuits, equipment, habitats, everything is exposed. Everything degrades. This is the reality of the moon. Not a peaceful satellite, but a harsh, unforgiving environment, shaped by billions of years of exposure to space. A place where dust behaves like a hazard, radiation never stops, temperatures swing wildly, and the ground itself can shift beneath your feet. We've been there before. But we were only visitors. We stayed briefly, gathered what we could, and left before the deeper dangers had time to reveal themselves. Now, as we consider returning, not just to visit but to stay, we are facing a very different challenge. Because surviving on the moon isn't about planting a flag. It's about understanding a world that looks quiet, but is anything but. And the moon, as always, waits, silent, distant, and far more hostile than it appears.